Now that we've talked about water as a solvent and how water can cause ionic molecules not only to dissolve but also to dissociate into their ions, I want to look at this a little bit more carefully because different ionic compounds have the ability to change the pH of water. pH stands for the potential of hydrogen, and it's a measure of the amount of hydrogen ion in a solution. Even in pure water, there's a certain amount of hydrogen ion, and that's because occasionally in a water molecule, the oxygen pulls a little bit too hard on the electron and takes it entirely away from the hydrogen atom. And that leaves you with a hydrogen ion, H+, and an OH ion, or what's called a hydroxide ion. In pure water, because every time we separate one water molecule, we get one hydrogen ion and one hydroxide ion, the amount of H and OH are the same. That's the situation that we call neutral. We can change the pH by adding different substances into the water. Acids are molecules that dissolve in water and separate to release a hydrogen ion. So anything that you put into water that dissociates to release a hydrogen ion is an acid, like hydrochloric acid. Hydrochloric acid, or HCl, is formed by an ionic bond between a hydrogen atom and a chlorine atom. When hydrogen chloride is put into water, it separates into H+ and Cl-. That changes the amount of hydrogen ion in the water. We have more hydrogen ion. Anything that releases hydrogen ion is an acid. A base is an ionic molecule that dissociates in water to release hydroxide ion, or OH-. Something like potassium hydroxide, that's KOH. When we put KOH in water, it separates into a potassium ion and the hydroxide, or the OH- ion. That increases the amount of hydroxide ion. The way that affects the amount of hydrogen is the more hydroxide you have, the more it binds to the hydrogen ions in the water, and then you have less and less hydrogen ion. So anything that has the ability to either release OH or to bind to hydrogen ions is going to be a base. An example of a base that binds to hydrogen ions would be ammonia. Ammonia, or NH3, can bind to a hydrogen ion in water. That lowers the amount of free hydrogen ion and changes the pH. Most ionic molecules that dissolve in water are not acids or bases. Anything that dissolves in water and dissociates into ions that doesn't increase or decrease the hydrogen ion is considered a salt. Sodium chloride is a great example of that. When we put sodium chloride in water, it separates into sodium and chloride. And neither of those is going to change the amount of hydrogen. We're not increasing or decreasing the amount of hydrogen. We're not changing the pH. That's a salt. A few other examples of salts would be magnesium chloride or lithium bromide. pH is measured on a scale that goes from 0 to 14. Something that's neutral, that has the same amount of hydrogen ion and hydroxide ion, like plain water, is at pH 7. So pH 7 is considered neutral, and the pH of pure water, same amount of hydrogen ion as hydroxide ion. The more acidic something is, the lower its pH, and the more hydrogen ion it has. This is a little counterintuitive. A lot of people tend to mix this up, that more hydrogen ion is lower on the pH scale, and that's what we have with an acid. The more acid you add to water, the more hydrogen ion is present in that solution, and the lower the pH. Solutions that are more basic are higher on the pH scale. The more basic something is, the larger the value on the pH scale. Some examples of common acidic substances would be things like pop, or citric juices like lemon juice, and stomach acid. All of those are acidic. A few common bases include baking soda, ammonia, and bleach. There are two important things to remember about the pH scale. One of them I mentioned already. As the amount of hydrogen ion goes up, pH goes down. As the amount of hydrogen ion goes down, pH goes up. The other important thing to remember about the pH scale is it's what's called a logarithmic scale. It's not linear. What that means is that for every 1 step change in pH, that's actually a 10 times change in the amount of hydrogen ion. So a solution that's pH 5 has 10 times more hydrogen ion than a solution of pH 6. A solution of pH 4 is going to have 100 times the amount of hydrogen ion as in a solution of pH 6. So even a small change on the pH scale is a big change in the amount of hydrogen ion. This is really important because the pH level at which cells function is relatively narrow. If the pH gets too high or too low, cells no longer function properly. Their proteins no longer fold up correctly and reactions don't proceed properly. So without the proper pH, cells are going to die. Just for an example, the normal pH of blood is between 7.35 and 7.45 on the pH scale. That's a really narrow range. And when the pH of the blood gets outside of that range, it means that something's wrong. Other areas of the body have different pH levels. For example, we already pointed out that the pH of the stomach is very acidic. That can be in the range of a pH 1 or 2. The pH of each area of a cell or each area of the body is important for the function of that area. And so we need to maintain the pH in the correct level for the area that we're talking about. In order to limit pH changes and keep the pH at the proper level, cells and blood and other areas of the body have what are called buffers. Buffers are molecules that can either bind to or release hydrogen ion as needed, and that helps to prevent changes in pH. For example, if I added a lot of acid to my blood right now, I added a lot of hydrogen ion, there are molecules, buffers, in my blood that will bind to that extra hydrogen ion so it's not just floating around free affecting the pH. On the other hand, if I accidentally added a whole lot of base to my blood, there are molecules in my blood that would release hydrogen ions to help counteract that and keep the pH where it belongs. So buffers are really important for maintaining the proper pH level so that our cells continue to function the way they're supposed to function. An example of a buffer system in the blood is called the bicarbonate buffer system. There's a molecule in your blood called bicarbonate that can bind to hydrogen atoms to form carbonic acid. So if you have extra hydrogen atoms in your blood, the bicarbonate in your blood binds to them so they're not floating around loose. That forms carbonic acid. So you also have carbonic acid in your blood, and if your blood pH gets too high, the carbonic acid will release hydrogen ions into your blood to bring your pH back down. This helps keep the blood at the stable pH that's needed for your body to function properly. There are lots of different buffers found in your blood and lots of different buffers in your cells.